Hey guys, here's our video on solving equations. All right, so when we're solving equations, what we're really doing is solving for the unknown variable. We're solving for the value that makes the equation true. So in this question, our variable is x, right? X is unknown. We don't know what x is, but x is representing some number, right? And what this is really saying is some number plus 9 is equal to 14. So when we're solving for x, we're trying to find out what number plus 9 will give you 14. So to do that, when we're solving equations, we use inverse operations, which is basically opposite operations to try to isolate the variable. Isolate means to get the variable by itself and then solve for its value. So just by looking at this, you can tell that the number plus 9 that would equal 14 is just going to be 5 because 5 plus 9 is 14. But sometimes with much longer equations, it's not always easy to see that. So how do we actually solve this algebraically? Well, the first thing we want to do is isolate this variable, right? Or we want to get x by itself. So notice that there is an equal sign right here. So there's a left side of the equal sign and a right side of the equal sign. When we're trying to isolate x or get x by itself, we're going to do inverse operations to move every other term to the other side of the equal sign. So for example, if I want to get x by itself here, I need to move this 9 over to the right side of the equal sign. That will let me have x by itself on the left side. Now, to do that, I'm going to use inverse operations or opposite operations. What does that mean? Well, if I need to move positive 9 over to the other side of the equation, I need to do the opposite of whatever is happening to 9. So notice that 9 is being added on the left side. So if I'm going to do the inverse operation or the opposite operation, then I'm doing the opposite of the opposite of addition, which is subtraction. So my first step would be to subtract 9. Now, since we have an equation, right, an equation is always equal on both sides, right? So when we have equations, we need it to be balanced on both sides. All that means is whatever operation we do to the left side of an equation, we must also do it to the right side. So whatever you do to one side, you do the same thing to the other side. So since I subtracted 9 on the left side of the equal sign, I'm also going to subtract 9 on the right side of the equal sign. Now, 9 minus 9 is just 0, so that's going to cancel out. We don't need to rewrite it as 0. We know it's going to cancel. Then I'm just going to drop down the x and rewrite it. X is equal to, and then 14 minus 9 is just 5. And that's my final answer. X is equal to 5. If we check this, right, if we went back and substituted 5 for x in our original equation, we would see that we would get an answer of 14. Just for practice, we'll substitute it here. So our original equation was x plus 9 is equal to 14. We just solved and found out that x is equal to 5. So if we substitute 5 for x, we have 5 plus 9 is equal to 14. 5 plus 9 is indeed 14, so 14 is equal to 14. This is a true statement. So we know that our answer x equals 5 is absolutely correct. All right, question 12. Well, question 2, question 12. We have x minus 8 is equal to 16. So steps are the same here. My goal is to isolate x or get x by itself. That means I need to get rid of this negative 8 by moving it to the other side. How do I do that? I just use inverse operation. So since 8 is being subtracted here, my opposite of subtraction is going to be addition. So I'm going to add 8 to both sides to get x by itself. So plus 8 on the left side. And whatever you do to one side, you do to the other side. So I'm going to add 8 over here as well. Negative 8 plus 8 is going to be equal to 0. If you have a negative and a positive of the same value, it's always going to cancel out. And that's always our goal here, to get x by itself. So negative 8 plus 8 is going to cancel out. And we're going to be left with x is equal to 16 plus 8, which is just 24. That's the final answer. X is equal to 24. Now, if you did went back and substituted 24 for x and you did 24 minus 8, you would see that it would be 16. You could also just check this on your calculator if you needed to. All right. Next, we have 3x plus 12 is equal to 24. So the steps are the same here. I want to get this 3x by itself. The only thing different here is now we have a coefficient in front of x. We have 3x. So there's going to be one extra step here. My goal is still the same. I still need to isolate the x term, or the term that has the variable x. I need to get this 3x by itself. So my first step is going to be to move this 12 over to the other side. Again, I'm going to do the inverse operation, or the opposite of whatever is happening to 12. Since 12 is being added here, the opposite would be to subtract 12. So my first step would be to subtract 12 from both sides. Now 12 minus 12 is just going to cancel out here, and we're going to be left with 3x is equal to 24 minus 12, which is just 12. So now I have 3x is equal to 12. I'm not done because I still need to get x completely by itself. Notice that we have 3x. When we have a coefficient attached to a variable like this is technically 3 times x. So if I need to get x by itself, I have to do the opposite of 3 times x. We know that the opposite of multiplication is division. So in this step, in my last step, I need to divide both sides by whatever coefficient is in front of x. So I'm going to divide both sides by 3. 3 divided by 3 is just going to be 1. So this is going to cancel out. And we're just going to be left with x, or 1x, is equal to 12 divided by 3, which is just 4. So here, x is equal to 4. All right. In this one, we have 7 minus 5x is equal to 27. So steps are still the same. I need to get the term with the variable by itself. So I want to get negative 5x by itself. I need to move this 7 over to the other side. Again, I'm going to use inverse operations. So since this is a positive 7, I'm going to subtract 7 from both sides. 7 minus 7 is just 0, so that's going to cancel out. And we're left with negative 5x is equal to 20. because 27 minus 7 is just 20. Notice that I rewrote negative 5x in the second line because in my original equation, I have a negative 5x. Remember, when we move terms around, we move it with the sign that's in front of the term. My last step here would be to divide both sides by negative 5 to get x completely by itself. Remember that this is negative 5 times x, and the opposite of multiplication is division. So our very last step here is to divide. We always divide by the number or the coefficient that's in front of x. And we also move it, or we also divide with the sign that is in front of that coefficient. So I'm dividing both sides by negative 5. Negative 5 divided by negative 5 is just going to be 1. So I'll be left with x is equal to 20 divided by negative 5, which is going to be negative 4. If you're unsure about dividing with negative signs, always double check using the calculator. So if we entered in 20 divided by negative 5, you'd see here that we get negative 4. All right. Our next question is 3 times x minus 8 is equal to 12. So now it's leveling up a little bit. We've got a distribution to do here. Anytime you see a parentheses and a number outside, we're always going to distribute first before we start moving anything to the other side. So 3 times x is just 3x. 3 times negative 8 is negative 24 and is equal to 12. So now I have the equation here. I need to get 3x by itself. So I need to move this negative 24 over to the other side. Remember, our goal is always to isolate the term with the variable or to get that by itself. So I'm trying to get 3x by itself. To do that, I'm going to add 24 to both sides. Negative 24 plus 24 is going to cancel out. And we're going to be left with 3x is equal to 12 plus 24, which is just 36. My last step here is to divide both sides by 3. I just want to address a common mistake that some students make when solving equations like this. Sometimes we're tempted to subtract 3 from both sides. And then we think that we're going to be left with x is equal to 33. This, however, is not true. This 3x is 3 times x. So we cannot subtract 3 from both sides and say that we're left with x. That would be saying if I had 55 and I subtracted 5, that I'm going to be left with 5. See, this is not true, right? So same thing for this side. If I have 3 times x and I'm going to do the opposite of multiplication, then I need to divide. I can't subtract 3 from both sides. So we're going to divide both sides by 3. This is going to cancel out. We're going to be left with x is equal to 12. And that's the final answer. All right. Next question. So we're leveling up a little bit again. Now we have 7x plus 2 times x plus 3 is equal to 42. So right away, I see parentheses, I see the number outside, so I know I'm going to have to distribute first. I'm not touching the 7x right now, so I'm just going to drop it down and rewrite it. So I have 7x plus 2 times x is 2x. 2 times 3 is 6, and that's equal to 42. Now, notice that on the left side of this equation, we have 7x and 2x. These are like terms. When you have like terms on the same side of an equation, you can go ahead and combine them, but they must be on the same side. So since 7x and 2x are both on the left side, I'm going to go ahead and combine these. 7x plus 2x is 9x. And then I have plus 6 is equal to 42. Now, I need to get this 9x by itself. So I need to move 6 over to the other side. So I'm going to subtract 6 from both sides. Subtract 6, subtract 6. 6 minus 6 is going to cancel out, and we're going to be left with 9x is equal to 42 minus 6 is just 36. And now I have 9x is equal to 36. My last step here to get x completely by itself is to divide both sides by the number that's in front of x. So I'm going to divide both sides by 9. This is going to cancel out, and we're going to be left with x is equal to 36 divided by 9 is 4. Always be sure to double check using your calculator if you're not sure with the adding and subtracting and dividing or the positive and negative signs. All right, question 17. So we have 5 times x plus 2 is equal to 3x minus 8. This question is a bit different from the others because now we have the variable on both sides of the equation. But my steps are still going to be the same. I'm still trying to solve for x. My first step here is going to be to distribute. So 5 times x is 5x. 5 times 2 is 10. All of that is equal to 3x minus 8. Now from here, what do I do? Well, I need to get all the terms with x's on one side of the equation, and I need to get all the constants on the other side of the equation. So my goal is to move this 3x over to the left side of the equal sign. I'm going to do that using inverse operations as well. So since this is a positive 3x on the right side, if I'm going to do the opposite, then I'm going to subtract 3x. And whatever I do to one side, I'm going to do to the other side. So I'm subtracting 3x from both sides of the equation because I want to move this 3x over to the left side. I want to do that because I want to be able to combine it with this 5x. So we're going to subtract 3x from both sides. 3x minus 3x is going to cancel out. And now we're going to get to combine 5x minus 3x. 5x minus 3x is just 2x. Drop down to 10, so plus 10 is equal to negative 8. Now I have an equation that looks like what I had before. Goal here is to get this 2x by itself. So I'm going to need to move this 10 over to the right side. I'm going to do the inverse operation, so I'm going to subtract 10 from both sides. 10 minus 10 is just 0, that's going to cancel out. And we're left with 2x is equal to negative 18. right? If you double check this in your calculator, I'll just show you over here. If you did -8 minus 10, you'll see that comes out to -18. Last step here to get x completely by itself is to divide both sides by 2. So I'm going to divide both sides by 2. This is going to cancel out, and we're going to be left with x is equal to -9. And that's our final answer. All right. So a little bit longer this time. We have 3x minus 2 times x minus 5 is equal to 2x plus 8. Right away, I know that I have to distribute first because I have 2 times x minus 5. I'm not using this 3x, so I'm just going to drop it down and rewrite it. 3x. And now I need to distribute. Notice that I have this subtraction sign in front of the 2. So this is technically -2. So I need to distribute -2 to every term in the parentheses, not just 2. Remember, when we move terms around, we always move it with the sign that's in front of it. When we're adding or subtracting or distributing, we're always using the sign that's in front of the term. So since I have a -2 outside of this parentheses, I need to multiply everything inside by that -2. -2 times x is -2x. -2 times -5 is +10. All of that is equal to 2x plus 8. Now, notice that I have 3x and -2x on the left side of the equation. Since these are since these are like terms and they're both on the same side of the equation, I'm going to go ahead and combine them before I move anything else. 3x minus 2x is just 1x, or just x. And then I'm left with plus 10 is equal to 2x plus 8. Okay, now I have x plus 10 is equal to 2x plus 8. I need to get all the x's, all the terms with x's on one side of the equation, and all the constants on the other side of the equation. There's two ways to do there's two ways to do this part right here. I'm going to show you both of them. The first way is to move all the x's to the left side. So I'm going to subtract 2x from both sides. This will cancel out, and we have x minus 2x, or 1 minus 1x minus 2x. Well, 1 minus 2 is just -1. So I have -1x, or -x, plus 10 is equal to 8. From here, I need to get this -x by itself. So I need to move the 10 over to the other side. So I'm going to subtract 10 from both sides. This will cancel out, and we're left with -x is equal to -2. 8 minus 10 is -2. My last step here is to get x completely by itself. X is not completely by itself here because this is a -x. I need positive x. Just positive x is equal to something. So we know that there is an invisible 1 in front of this x. And this is now -1 times x. The inverse of multiplication is division. So if I'm going to get rid of this -1, then I need to divide both sides of the equation by -1. The negative ones are going to cancel here, and I'll be left with x is equal to -2 divided by -1 is just +2. So my final answer here is x is equal to 2. All right, I'm going to show you the other way to do this. That's a little bit easier, where you don't have to divide by that -1 at the end. Right, so again, my first step is still going to be to distribute. So I'll have 3x, -2 times x is -2x, -2 times -5 is +10, is equal to 2x plus 8. So again, I have 3x minus 2x on the same side. These are both like terms, so I can just go ahead and combine them. 3x minus 2x is 1x, or just x, plus 10 is equal to 2x plus 8. Now here's the step where we could do something a bit different. Previously, I subtracted 2x from both sides. This made me have a negative x on the left side. And because of this negative x, I had to end up dividing by -1 at the end. What we could do differently here is, instead of moving all the x's to the left side, I can move the x's over to the right side. Because here, this is just a 1x. So if I subtract 1x from both sides, this will go away, and 2 minus 1x is just going to be a positive x. So I would not have to divide by a negative. Let's see how that works out. So I'm going to subtract x from both sides. X minus x is going to cancel out. I'm going to be left with 10 is equal to 2 minus x is just going to be 1x. And we have plus 8. Now I have 10 is equal to x plus 8. Again, I need to get x by itself. It's okay that x is now on the right side. I could still try to get it by itself on the right side by doing the opposite of adding 8. So I need to move this 8 over to get x by itself right here. So I'll subtract 8 from both sides. 8 minus 8 is going to cancel out. We know that 10 minus 8 is just 2, is equal to x. And here is the final answer, which is what we got previously, but we had to just do it a bit longer and divide by -1. So essentially, when you have a question like this, and you need to move variables over to another side of the equation, check to see which side would allow you to keep the variables positive. So instead of subtracting 2x here, I can instead subtract x and move them over to the right side. We always want to try to keep our variables positive so that we don't have to divide by that -1 at the end. All right, that is it. All right. So when we're solving for equations, all we're doing is isolating the variable, or trying to get it on one side of the equation by itself. And to move terms to different sides of the equation, we do inverse operations, which is opposite operations. So if something's being added and we need to move it, we're gonna do the opposite, which is to subtract it. If something is being subtracted, we're gonna do the opposite, which is adding it. And then our last step, when we have a number in front of the variable, that's multiplication. So our inverse operation would be to divide. All right. Hope this helped. Bye.